Hello, I'm Roger Sheely, rangeland weed ecologist with the Agricultural Research Service and the Eastern Oregon Agricultural Research Center, and I'm here to present an Eastern Oregon Ag Minute. It would have been fun to see the smile on the face of the first farmers and ranchers who used 2,4-D when it first came out in the 1940s. They didn't know how the herbicide worked, but they sure liked killing weeds. This week we'll discuss how the most common rangeland herbicides kill weeds and how you can get better control with the herbicides you use. 2,4-D is a member of the group of herbicides including Tordon and Banvel that are hormone mimickers. Naturally, plants have an intricate hormone balancing system that regulates their growth in response to environmental conditions. These herbicides inundate the plant with a hormone that ruins the natural balance and keeps the plant growing and growing until it exhausts itself to death. At proper rates, these hormone-mimicking herbicides do not affect grasses because grasses have the ability to metabolize the chemicals before they ruin the balance of natural hormones. When grasses increase after weed control, you get more feed for your cattle, and you'll be smiling too. This week, we're discussing how herbicides work and how to get them to work better. I like the farmer who said, "I hope it rains." Well, not for me, for my son. I've seen it before. One way to get herbicides to work is to make sure you apply them in weather conditions that allow more of the chemicals to get into the plant. For most herbicides, moderate temperatures around the 70s and no rain for a couple of days after applications work best. It's also important to make sure that the plants are actively growing, and that's why spring applications often work best. However, for Tordon, I think the best days are when a little mist is occurring. Tordon is taken up by the roots as well as leaves. If it gets into the soil, Tordon stays around longer and gives the plant a better chance to get more of it. This is not the case for most herbicides, only Tordon. Tordon also can be applied in the fall, which is a great time for controlling rhizomatous weeds like Canada thistle and Russian knapweed. Remember, this herbicide stays around a long time in the soil and will keep many broadleaves from regrowing for several years. So especially don't use Tordon where you plan to grow alfalfa, and please be sure to read the label of all the products you use. I hope it rains, just not on your cut alfalfa. You know, controlling weeds isn't rocket science. The most likely problem getting good weed control is improper or no calibration. Sprayer calibration isn't really complicated. All you need is to know how much solution you're putting on an acre. You can fill your tank up to say 60 gallons, spray a known acre with water, and see how much water you use. If you're spraying 40 gallons per acre, then for each 40 gallons in the tank, put the recommended rate of the herbicide you're using. If my recommended rate is 1 pint and I spray 40 gallons of water per acre, I would put in 5 pints in a 200-gallon tank. This may sound complicated, but for the money it costs, making sure you are properly calibrated is essential. No, managing weeds isn't rocket science. It's a lot harder than that. Think of a hot Saturday afternoon. You've been bucking hay all day. You're hot, sweaty, really tired. You reach for a tall, cold beer, open it, just take one small sip to get the dry out, and then the can's empty. That'd be pretty disappointing. Sometimes weed control can be pretty disappointing too, because in most cases only about 10% of the herbicide in the can actually gets into the plant. Herbicides pass through several layers of tissue before they can enter living cells and do their work. The first and most effective barrier to herbicide absorption is a waxy layer covering the entire plant called the cuticle. This protects the plant from excessive water loss. Because plants have several waxy layers, herbicides can have difficulty penetrating leaves. When the plants you're trying to control have thick, waxy layers, like Dalmatian toadflax, or lots of hairs on the leaves, a surfactant can help. A surfactant lowers the surface tension on the leaf, the water droplet spreads out, and has more surface area on which to enter the leaf. In studies, inexpensive non-ionic surfactants have worked as well as more expensive types. Surfactants are not always necessary, but can be very helpful getting more herbicide in the plant so it can do its job. Just a word of caution, putting surfactant in your beer, that won't help. This week we've been talking about making herbicides work better. When we spray herbicides and kill plants, we open niches that were filled by the weed, and if we don't get something into the open niches, the weeds come right back. So plan to make sure that there's enough desired species where you control your weeds, or think about planting something in their place to occupy their niche. A famous doctor summed up this principle pretty well. He said, "And N is the letter I use to spell notches, who live in small caves known as niches for hutches. These nutches have troubles, the biggest of which is the fact that there are many more nutches than niches. Each nutch in a niche knows that some other nutch would like to move on to his niche very much. So each nutch in a niche has to watch that small niche, or nutches who haven't got niches will snitch." I'm Roger Sheely. Thanks for listening. Have a great weekend.